Thank you for taking this opportunity to learn a bit about the School of Physics and Astronomy at Minnesota. We have about 180 graduate students, a faculty of 60 physicists and astronomers, and we're in 2 buildings, and we have, in addition to our core academic programs, 2 institutes. The building you're seeing now has actually been the home of the school for almost 100 years exactly, built in 1921. It was recently renovated in 2017. It's been the home, for example, to the first separation of uranium-235 just before the Second World War by Professor Al Nier, who was in essence the father of mass spectrometry in the United States. In more recent years, we've been home to some of the pioneering experiments in thin film superconductivity by Alan Goldman's group. And we're lucky enough to have on our faculty several award winners in the various subfields. We're distributed over several subfields. The largest 2 are condensed matter and high energy. In condensed matter physics, we have approximately 7 theorists and 7 experimentalists, predominantly in so-called hard condensed matter topics like magnetism and superconductivity, semiconductor physics. High energy experiment, our prominent experimental efforts are in neutrino physics and also at the Hadron Collider at CERN, the so-called CMS experiment, and a somewhat smaller effort, but in a burgeoning field, which is the dark matter searches and other exotic particle searches. We have an historically important space physics group, which is studying both space plasma physics as well as the physics of the sun, and a nuclear theory group, which sort of spans several topics, including nuclear astrophysics and really areas that really merge into high energy theory. Among our newer fields is biophysics, where we have 3 experimentalists and a couple theorists who bridge it, perhaps between biophysics and condensed matter. And finally, in cosmology and astrophysics, we have people doing cosmic microwave background search, as well as gravitational wave searches. And then in the Minnesota Institute for Astrophysics, there are another 10 astronomers who bridge both what I call traditional observational astronomy as well as theory and things like looking for mergers of compact objects using multi-messenger astrophysics, which is one of the fastest growing fields. So we're members of the Compact Muon Solenoid experiment at CERN, where 3 faculty participate, including 1 who just joined us. In other parts of the high energy group, we have a long-standing effort in neutrino physics that derives from experiments that began here 40 years ago, and were among the first in the world to go deep underground to look for particle phenomena, and in recent years that has been neutrino searches. And our most recent new faculty member in neutrino physics is a member of the long baseline experiment DUNE, which is essentially the next generation of neutrino physics experiments. In dark matter, we're members of the CDMS experiment, which is now based at the Sudbury Neutrino Observatory in Canada, right? And we are participating in several astrophysics collaborations, including the Keck and South Pole telescopes at the South Pole and Antarctica. There are proposals for a couple other balloon-borne cosmology experiments, and we have various types of memberships and telescopes around the globe, including the Large Binocular Telescope in Arizona, in which we're one of the primary institutions. One of the most exciting collaborations, you've probably heard a lot about it in the news the last few years, is the Laser Interferometer Gravitational Wave Observatory, LIGO. And this effort has recently expanded into what's known as multi-messenger astrophysics, that's correlating what they see there with other types of observations. And in that field, we actually just started a large training grant funded by the National Science Foundation, in which students from both physics and astronomy, as well as fields like computer science and statistics, will be participating.
Most importantly for you is that the Fine Theoretical Physics Institute is a home of a number of world-class physicists who do research in a very wide area of modern theoretical physics. It ranges from high energy and cosmology and elementary particles, field theories, and goes into condensed matter, superconductivity, quantum computing, disordered systems, semiconductors, and many others.
So I study X-ray emission that comes from the sun itself. We also have other people in the space physics group who look at the effects of emissions from the sun as they go through the interplanetary environment. There are people studying the impacts on the magnetosphere and the aurora at Earth as well. So we really make the connections all the way from the sun to the Earth. There is a long history of building instrumentation to do these sorts of things. So Minnesota has had its hands in making a lot of instruments that have gone on interplanetary missions, including an instrument that is on the Parker Solar Probe, which is one of those spacecraft that is getting much closer to the sun than we ever have before. So the University of Minnesota is really all over the solar system.
Well, I would say in the next 5 years, some of the main things that we're interested in understanding are why the atmosphere of the sun, the solar corona, is so very hot. So it's millions of degrees, but the photosphere, the part of the sun that we see, is only tens of thousands of degrees. And what heats the corona is kind of a mystery at this point.
High energy particle physics, our goal is to discover what the new physics is. We know that physics, as we understand it, is not the complete picture. So we know that things are wrong with our explanations of physics. We know there's new physics out there. We just don't know what it is. And so pretty much all of high energy physics takes different directions to try to explore what's out there to see if we can find what the new physics is.
So in high energy physics, what we do is we study the fundamental nature of particles, of the universe, of the known particles in the universe, and also looking for those which occupy a large fraction of the universe, right, which we don't know about. So in high energy physics, in our group, so we have people working on neutrinos, we have people working on collider physics at CERN over in Switzerland, and we have people working on a experimental Fermilab, which is measuring a very exotic decay of the muon, which is one of the fundamental particles.
So high energy experiments right now is a pretty exciting field. There are a number of big questions that we're trying to answer. These range from where do neutrino masses come from, what is dark matter, where does the Higgs really come from? What's the origin of the Higgs and the Higgs mechanism? Why does it have the mass that it has? And these are all questions that we have experiments right now that are operating, that are being constructed, that will provide input on those kind of questions. We have people working, such as myself and a few other colleagues, on experiments at the Large Hadron Collider, where we have collider physics, but we also have an active group in neutrino physics, dark matter experiments, even cosmology. So, and the strengths of Minnesota in terms of high energy physics, I would say on the collider side, we have a really strong group in calorimetry and on detector electronics. So these are the electronics that live really on the detector. They have to be exposed to radiation. On the neutrino side, we have experts in liquid argon technology, which is something that's sort of an up-and-coming technology that will be used for the foreseeable future in neutrino physics. So
Minnesota has hosted the last 2 long baseline neutrino oscillation experiments in the US. And they've been competing with the Super Kamiokande detector in Japan and the K2K and T2K experiments over there. So we're involved in the NOVA experiment, which is based in, the FAR detector is based in northern Minnesota in Ash River, which is a University of Minnesota owned site. That is the world's largest plastic structure. And it is something like a 14,000 ton neutrino detector. We have data analysis ongoing, and that is going to be continuing to take data for the next 2 to 3 years.
We got involved in what's called the cryogenic dark matter search, or CDMS. And what we're doing now is we're building a larger and more sensitive detector and a complete experiment in a deeper mine so that we can get rid of the backgrounds which can affect our ability to see dark matter. And this new experiment is called Super CDMS.
Condensed matter physics is the biggest field of physics. We are interested in a lot of different problems involving how electrons and atoms behave in a microscopic scale. The most interesting, in my opinion, problems that we have ahead of us involve what is called quantum matter, which is how when you put a lot of electrons together, how they interact and how they collectively behave. And a lot of times the way that they behave collectively is very different than the way that they behave as single electrons. So this leads to this concept of emergency and so on. And another area that you've probably heard of is quantum computation, is exploiting quantum mechanics to develop computational frameworks, which could really revolutionize the way we do computation and transmission of information and so on.
Then finally, there is a sense in which condensed matter is only a couple steps removed from the world of applications, things like solar cells, memory and computers. A few of us are working on topics that are more applied in focus, but in which we still use the tools in our physics toolbox to work and understand new materials.
The department has become more and more aware of the needs of a diverse range of students also. So when I came, there were only 2 women faculty, and now we have lots and lots. And so that's been a great change in terms of the culture.
I joined the group because they work on a lot of interesting things. What I work on in terms of physics is very complementary to what the other people in the group do, so that works nicely together. And in terms of hardware, there's a nice synergy. I've worked on related, also electronics before, and so you really want to have your group be strong, and so that worked out nicely.
The reason I decided to come here was that Minnesota has this really rich history in neutrino physics, and the group has just got such a lot of stuff going on, and the group is very supportive of all of those efforts. The history in neutrino physics is a huge selling point to me as someone who loves neutrinos, and the summers are lovely.
I mean, I certainly like Minnesota. I've been here for a long time, and I think most of the students like Minnesota too. It's typically rated one of the most livable places in the country, and so Minnesota is a nice place to be, just in terms of being, the university is just outside Minneapolis. You can walk to downtown Minneapolis from the university. There's a lot of things to do. And then the university, I think, is a good place. We try to be a very collaborative and congenial place where students and faculty talk to each other and people don't feel constrained. We try to keep the competition dialed low so that people don't feel they're competing with each other, but are actually working with each other for making everybody better.
In addition to things like theater and music, there's a great park system, and of course, lots of woods in northern Minnesota. And there are student groups, including within physics, Grad Phi, which is our graduate student organization, as well as the Women in Physics and Astronomy, as well as groups that integrate with graduate students in other parts of the university.
I think in general, the theoretical physics group here, and I'm including particle physics and nuclear physics and condensed matter physics, is very strong and very diverse and broad, and also very friendly. Outside of academics, one thing that's great about University of Minnesota is that it's basically in the city, but not literally downtown. So there's lots of stuff to do around here. Minneapolis is a great place to live.